All right, guys, let's continue with the next part. So, last few lectures, I have talked from very basics about the networking, and I explain you in such a way that you guys, if you guys was or is in new in networking world, you can easily interpret and connect the dots, right? How the things work together. I know I was slow, but it is not about I wanted to be slow. My main focus, we are not into the workshop. Actually, we are into the training, and my intention is to train you guys. And not everybody know the concept of networking and netting and router and switches and netmarks, subnets, all the things, right? So I first explain you things from very basics, then I'll explain you how this thing work together. And the interesting thing is the way I explain to you, okay, same concept can apply to any of other technology wherever we require networking. For example, if you go to Dockers, you go to Kubernetes, if you go to some other framework, uh, private cloud, public cloud, right? The concept is exactly the same. The router, switches, netmask, subnet, SNet, DNet, right? Everything is exactly the same, and the use case wise is also they are same. So the summary of my last few classes, we have talked a lot of thing about VPC, but yeah, a lot of thing is there in the VPC. But I told you guys multiple time, my initial focus is to touch almost all the major services of the AWS. Okay, with explain the concept first, then show you how the things work. That's what we are doing here. But as you become guys comfortable in almost all the major service of AWS, then we start again touching these services, okay, from the next level. Okay, what I mean by this, for example, if you go to next topic, okay, maybe there you require S3 or VPC or EC2 or IAM. Okay, maybe any other service, maybe CloudFront. So all the services we plug together, and on those services we will add some more new feature, because there might be possibility, and there is actually, okay, there is some component on the S3 that is dependent on IAM. There's some component IAM that might depend on maybe some other services. So if you don't know what is VPC, okay, if you don't know what is IAM, it would be harder to explain you that advanced concept or some extra feature of that particular of services. So don't think, for example, we completed the S3 or we completed the IAM. We touched those things. At least you guys are now a little bit comfortable on S3 or IAM or VPC, but we keep on talking about those services in the future classes. Okay. So sorry. So guys, in the last class we talked a lot of things of VPC. I would like to take you one more new, very new service today, and you'll see when I take this new service again, that service also requires some of the knowledge of VPC. Okay, that service again requires some of the knowledge of security group of VPC or EC2 or EMI, so AMI and all the other services also. Okay, so guys, today's agenda is okay. Today's agenda is we are going to start one more new service, very useful service. We always want that service. Plus, it's not like this. We always sometimes we always configure from ourselves. If you go some other different services from AWS, for example, if you guys know about Kubernetes, so AWS has one their own service called EKS. That's called Elastic Kubernetes Services. So that service also required that service that I'm talking about today. Okay, so my plan, guys, for today and the agenda for today is we're going to start a topic called ELB, Elastic Load Balancer. So the whole day will go in this service, or maybe it's a big service. If I explain you or want to complete, maybe I can complete in 15 minutes, but I will like to go in depth. For example, we might discuss about how we can establish the stickiness, or how we can improve the performance, or how HTTPS termination work, or maybe cross zone load balancer if you want to configure, or maybe connection draining. So these are the some of the concepts, internal concept of ELB. So we'll try to touch, guys, as much as concept of the ELB. Okay, and there are a lot of different kind of ELB available here, so we are going to touch all the ELB in this training. But I would like to start the things from very zero, and before we start, I would like to first explain you the use case, and that use case automatic bring us and to the new service that is called ELB. At that time, guys, I will explain you what exactly ELB is. So first, let's go for the use case. What exactly we are looking for. So till now, you guys know at least one thing, that if you want to launch the configure the environment, or the for this you require instances. If you want to launch the instances, we have only one service available, or I can say main service available, called EC2. So EC2 will launch the instance in OS or environment for you. And in this environment, what we do, we will we will configure some services, maybe web services or databases, xyz, what I want to do. Okay, but final motto, guys, we are going to configure this service. One of the main reason is, right, we want to serve our application or website to the client. A client would be anywhere. Okay, so maybe if you're working in the microservices world, we will take talk a little bit about microservice in this AWS training somehow somewhere. Okay, so either you are in the microservices world or not, maybe you are directly dealing with your client and the customer, or whatever architecture you have, that is not important here. The important point here is, if you have some client and a user somewhere on the internet, or maybe somewhere on other network, maybe. Okay, they would like to connect to the services. Okay, now the important point over here is, right, this website or web service is running with your website or web application, maybe let's say ecom. Okay, and then, now, guys, you guys know 2020, the entire business, I can say, around the world is purely based on internet, or purely based on the website and the web application. So for the companies and for the businesses, okay, this OS is very critical, right? So you can think this OS is like a company, nowadays, like a company corporate house. Okay, and if the corporate house is down for a day, they will lose my billions and millions and billions, maybe depend, guys, business to business, of dollars, right? Okay, so what I'm talking about finally, okay, for the company, for the corporate, this operating system is very critical in all the firm. Okay, and one of the biggest firm, the critical is, they don't want this OS to be down. Or why we need this OS? I want my applications to be always running. Okay, so I never want my applications to be down in any of the cases. Okay, but the guy challenge is, nobody in the world can give you the guarantee. Even the AWS say, I will give you my EC2 instances. They are very much optimized. They're very much highly performance oriented. They never goes down. Or you launch this EC2 instance in let's say in 1A data center or AG. Okay, but even though, guys, nobody can give the guarantee. Maybe some physical disaster come up, tsunami come up, earthquake come up, the entire AG goes down. And like this is about the only just as a information, they has happened multiple time in the past. Some kind of physical disaster come up, and the entire data center goes down in Amazon, plus in Google, Facebook, other companies also, right? It's not about AWS only. Okay, so nobody can give the guarantee. Or maybe your applications running on the top of some of the operating system, the hardware fail. Hardware has a life, guys, and they can fail anytime, right? They fail. RAM fail, SMPS fail, power supply. Maybe you have backup power supply, but they fail. So to overall, guys, motto is what I'm talking about here is, right. Okay, I don't want my applications to be down for the client, because for me it is a business, it's a complete business. If they're down for 2 minutes or 1 minute, I might lose two things, right? One, I lose business for that. In 2 minutes, maybe every minute you earn some thousands of dollars. And the biggest thing you lose is your reputation. Like, even though, guys, if you see recently about the Google and YouTube down for some 10 to 15 minutes, so actually it's not about, they might not lose the business, because the customer of the YouTube again come back to view their videos. But the reputation the company lose, right, they normally won't get it back. Okay, so for the big companies, the things that matter a lot is their reputation also. So the overall need is, guys, the overall requirement and the use cases. I don't want my entire this box goes down in any of the cases. And interesting thing is, you guys know, if you want to run any applications, right? You need a OS, and for the OS you need EC2. For the EC2 you need network card, you need router, you need switches, you need VPC, subnet, internet gateway, net gateway, availability zone, tons of things we require. And one of the part will miss, has some kind of issue, the entire connectivity from the client to your final applications, client will lose. Okay, that's called downtime. So they will face the downtime in your application. Okay, so how to resolve it, this challenge, and how you can give better, maybe around 100%, 99.99% uptime. Okay, there will be lots of things we have to plan. One of the plan we can do is something like this. Okay, and here your knowledge of VPC and NetMask will help you. So technically, technically, if you want to create a setup that, to think in a way that you don't have a control, thing can fail any point in time. Even though they fail, my client won't lose the connectivity, they still uh, access my final application. Okay, final application. I just want to give one word here. You guys might know, but for the customer, when they want to connect this application, all right, they will have some URL. Sometimes, guys, this URL is also known as endpoint. Most of you guys might know this term, but maybe not, right? So this is the endpoint. So for the customer, they always reach to the endpoint, and there will be no downtime. Technically, I want uptime. Okay, so how you can, guys, achieve this? Multiple way or multiple angle we can plan the strategy setup, right? But one of the commonly used way to implement this kind of uptime is to create a load balancer. Okay, uh, normally it is known as load balancer, but they have a lot of extra benefit. You guys might know what is load balancer, but load balancer give you lots of other benefits also. Okay, so but let me very quickly explain what a load balancer, those who by chance don't know what exactly the meaning of load balancer. Okay, but motto and goal is clear. Okay, for the customer point of view, right? My business want show them the disconnectivity, or and giving a not giving the services to the final customer. I won't keep on giving my services to my customer. Okay, so what can you do, guys? What can you plan, right? So we can plan something like this very quickly if I try to demonstrate. So let's say this is the entire office we have. You guys know it's called VPC, and in this VPC we have multiple labs, and you guys know this lab is known as subnet. So good strategy and plan, say, guys, to solve this issue from the disaster. Okay, and we should have some recovery plan, DR plans. So one of the disaster recovery plan or strategy, you can say, one of the, I can say, is this one. So whenever you create your VPC, um, always create at least two subnet. Let's say subnet 1 and subnet 2. And the good plan is, guys, whenever you create a subnet, okay, always create a subnet, okay, in different data center. So let's create this subnet in 1A data center, let's create this subnet in 1B data center, or I can say availability zone. Okay, so what is benefit of this? Okay, as a cloud admin, or as a cloud architect, guys, right, you have to plan your application deployment. Means you, somebody has created your website, let's say in PHP or Java something, and you run on the top of web server. Okay, so that anybody can access your application from outside world. So that is normally known as deployment. So while deploying your application, or I can say before deploying the application, you have to properly plan for disaster recovery also. Okay, so it is something like this. It's something like this. So as a cloud architect, you create your own VPC, two subnets. You guys know how to do, and you guys know the main part of the subnet is when you create a subnet, they always ask which data center or which zone you want to launch. So as a good architecture, you say I want to launch. I want to like to create two subnet. Why? Because my plan is to launch one instance here, and on the top of the instance, I would like to deploy my web application. Okay, but now this time, because for the my business, for my company, this application is very critical and we can't reply anybody in the world because nobody can give the 100% surety or the guarantee. So as a good planner or the strategy guy, I will create my own design. Okay, and my design is this one, that what I'm creating here. Okay, so my design is I will like to create exact copy of the EC2 instance here. Okay, so EC2 instance will I will install a same instance, and I will launch the same application over here with the same code. So technically, these are the two instances running in behind this in AWS. Obviously, because there are two instances, they will have a different IP address, and this guy will have a different IP address. Okay, now why we launched two? So guys, interesting thing if you notice here. Okay, I launched two instances, and you guys know if you want to create a same copy of the instance, either you launch by yourself and configure, or you can use AMI. Okay, so create one AMI, or you can custom AMI, and this AMI configure everything from the scratch. And use the same image to launch this guy, use the same image to this guy, so everybody has a exact copy, or both the instance will have a exact application running with the same configuration. So you guys know how to configure AMI, and I will explain to you the use cases of it. Okay, but finally in this example, what happened? What happened? Okay, let's say this is my final customer or client, and we will provide IP one to the customer, and customer will come somehow. You guys know how they come up, right? They reach here, and they keep on accessing the website. But now maybe there might possibility some kind of downtime come up. Maybe this instance goes down, hardware failure, or entire data center AGs goes down. Okay, so in this case, what we will do, we can tell the client, by chance, if you feel one of the IP goes down, it's called fail. If something fails, so I recommend you, because you're my very very critical client, very important client. So I recommend you, I'm giving you one more IP. One more IP. Do one thing, just go to your browser and change the URL and connect to this guy, or because they have the exact copy. Exact copy, so you will continue access my application, the whatever you access, you are accessing over here. So technically, this is called failover. So please do the failover. Okay. So in this case, the good thing is, in this case, the good thing is, client is keep on accessing the application. But the bad thing is, right? How can you tell the client if one IP goes down? Connect to the second. It is something like this. Google tell us that one of our website URL is www dot sorry google1.com, and if the w1 google.com goes down, so just type google1, google2, google3. So none of the client will like this, right? Okay, so it's not a good experience for the client. Or we can't tell all the IP to client, because for the big corporate, big applications, right, businesses, there might be thousands of instances running behind the scene. Okay, so normally what we wanted to do, I don't want to client, I don't want to give all the IPs to the client or all the endpoints to the client. Okay, because client can't remember those things. I don't want to type again and again to the new URL. Okay, so what can we do? We can create one program here. Program here. But by the way, guys, let's talk before the program. This very simplest architecture, or I can say design, okay, will at least give you a benefit of feeling the thing. Okay, if one goes down due to any reason, or my entire data center goes down, your application is still running in other data center. Right, even though any physical disaster come up, you guys know one of the data center run in some location, other run in maybe 100 miles distance, so it won't impact the any physical disaster there. Okay, so this is one of the very typical disaster recovery kind of strategy we implement. So this architect guys solve the challenge what I was discussing here. For the business, your application will have almost 100% or 99% uptime. But in this architect, a lot of management kind of issues come up. One of the management issues that come in this architecture is I don't want to give a client multiple IPs. Okay, to solve this is for solve this one of this issue. Okay, we can create one program here. Okay, and think this program is not a program, it is again one of the instance we have. Instance means the operating system we have. Okay, and because this is the operating system, this operating system will have some IP address, let's say IP address 100. Okay, now the good thing is what we will do now from onwards, we'll tell my client, okay, for if you want to access the application, my actual application is running on the IP 100. So what I want, if you want to access my application, just connect on the IP address 100. Just connect over here. Okay, but technically in this instance, we don't put any of our main application. What we will tell to this instance or to this operating system, that you are just a intermediate or mediator. Whenever any client come to IP 100, okay, IP 100, take the request from the client and just trying to give them feel that you are actual web application, real web application, but you're not. So when the client come to you is the first step, right? Client request to you. For the client, you are the server, but you are not. So what you do, take the request from the client and on the behalf of the client. Okay, guys, understand one thing. This is not the router. When you use the router send, take the packet and send as it is to the next router, to the next computer. Okay, it's called routing. So we are not doing any routing. This is also known as forwarding. We are not doing forwarding here. So what this system will do, they hold the request, okay, from the client and recreate a new request, or I can say recreate a new recreate a new packet and send this packet to the main web server where the application is run. The main web server. Okay, so for this main web server, they feel request is coming from IP 100. So for the main web server, right, they think IP 100 is the client. So this is second step happen here. Okay, so whatever request they come up, they will send to the IP 100. They think they are client. So the duty of IP1 or web server is done. And what IP 100 do? Okay, because they get the request from the main server, so they again reply on the request, whatever request they hold in the first step. So they will reply to the client. So finally, in this example, according to the client feel, let's say client is running on IP 200. So IP 200 feel IP 100 is the real web server because they request to that guy and they are getting the reply from that guy. But IP 100, no, I am not. So from the client behalf, they send the request to the internal main application and send it back. So it work like this. So what is the benefit of this, right? The benefit of this, guys, benefit this, for the client, we are providing IP 100 as a one fixed static IP. We don't change this IP. They have to remember only one single IP 100. Well, but behind the IP 100, what we'll do, we can create multiple computer, IP1, IP2, IP3, IP4. Okay, and typically in this world, these computers are known as backend server. So we can create as much as backend server, because we can get hundreds of backend server, hundreds of backend server. So every computer will have own IP. So every maybe have 100 different IPs running behind the scene, but for the client behalf, they can only see one IP 100. So I can say for the client, their endpoint is always IP 100. IP 100. But for the IP 100, there will be a lot of computer keep on connecting. Okay, and the good thing about this computer is the computer is, or I can say this instance is, there is IP 100. Okay, whenever there's two computer running, let's say we need one more computer here, IP3. Okay, so as the one more computer come up, so this computer will go and connect to this instance. Okay, this is called a registry. So we have to register our computer, means our backend. And the good thing is, guys, let's say this computer, let's say IP 131. Okay, so client don't have to know that new computer IP 131 come up. For them, there is only one endpoint IP100. But behind the IP100, there might be hundreds, or maybe one, or maybe 2,000 different applications running, or a different endpoint running. Okay. So what's the next benefit of this? The one benefit, guys, if you try to understood, client has to know only one single endpoint. So it's a good in terms of management. Okay. So this is one thing. Okay. Second benefit of this approach that will come out of the box. But by the way, guys, this concept that I explain you here, that the client will only send a request to IP100. IP100 will send the request from the client behalf to the backend server. Typically, this concept is actually known as a reverse proxy. Reverse proxy. Okay. Okay. But when you implement the reverse proxy, so out of the box, you will get one more extra benefit, and the benefit is that your this reverse proxy program has to implement that. Normally 99.9% always they have this benefit, and the benefit is called load balancing. So what IP100 will do, IP100 will do, whenever 200 come to IP100, the the first client come up, because obviously in the internet we have millions of clients. So when the first client come up, they will send the request to IP1. Second client come up, they will send the request to IP2. Third client come up, they will send the request to IP131. it means it means okay, it means every computer will get a request one by one. So it is not like this. Just you can think in this way. Normally, guys, whenever you configure any application, for example, in EC2, or you launch any application, let's say you create a website in Java. Or guys, whenever you create a website in Java, that's called application. And for launching the application, we need an application server. Or one of the application server name is Tomcat, or a JBoss, or WebSphere, or Glassfish. Multiple application server come in the market. Or let's say you create an application in PHP, and for PHP you need a web server. Let's say Apache web server. But normally every web server or every application server has some kind of limitation in the terms of connectivity. Okay, by design, or due to some other performance reasons also. So just for example, let's think this application can connect maximum at one single point in time 200 requests. So 200 client they can connect in parallel, and they serve in parallel. But there might be possibility, okay, whatever application you are running, or what application your business launch, they become viral. They become viral. Not viral, they might be point or maybe some point that in one point in time, in one point in time they will get more than 200 requests at a time. And if you got they get more than 200 requests at a time, for example 201th request, okay, that time applicants say hold down, I'm keep on serving my I was serving my last request, wait. Or sometimes they say fail, the connection throttle, or not throttle, we don't have a proper resources, some kind of error come up. So again, it's a loss of the client and plus the reputation also. So in this use case also, in this use case also, uh, a concept of load balancer help us. So what load balancer help you? First, they send a request to IP1, then IP2, IP3, 1, 2, 3 is keep on sending. This concept is called, or this strategy I can say, is called a round robin. There's more strategy we will discuss, but one of the common strategy we use in the load balancer called a round robin. Okay. So as an architect, you can design and you can sit with your business guys or management team, and you can ask them what's your target, your goal in your business. What do you think? How many maximum client at a point in time they will come in the future, because you are start marketing your business or new website or new product. So they say maybe I will have mostly maybe at one point in time 550 clients come, and because your technical guys know one computer can accommodate 200 requests, so they can put three computers behind the scene. So total three computer will accommodate 600 requests at one point in time. Okay, so those lots of things is involved, but to implement as a technical perspective, we need a load balance. Okay, so typically, likewise there will be lots of things we can achieve here, but very commonly concept that we need here is reverse proxy, Why? It will help you to solve one challenge called single endpoint. This can be done by reverse proxy. Plus, out of the box, reverse proxy come with the one more extra benefit that always enable by default is called a load balancer. Okay, and load balancer help you to balancing the load. If load increase, okay, we keep on sending this guy. Okay, and one more benefit, guys. By default, reverse proxy come okay come as a benefit. Okay, benefit is the load balancer, sorry, the reverse proxy here. Okay, a reverse proxy here, let's say IP100, because whenever guys new application you launch, for example, you launch in 1A, IP2, IP131. So when you launch this EC2 instance, what this EC2 instance contain, your application, your e-commerce site, for example. Okay, so this guy has to register. After we register 131 means my backend to IP100, and by chance this IP100 is also known as front end because they are the one who is front in the front line, and they will are the one who will directly connect by the customer. So so whenever any new computer you launch, why you launch one more, maybe right now they have three computers, for example 600 requests you can solve, or maybe you have more computers come up in the future. Okay, so you got one more computer, but whenever you add one more backend, you have to register your backend to the front end. So front end, no, now one more IP come up is called 131. Okay, so they register to this guy. So so interesting thing is, guys, normally your front end always do because IP 131 or 2 or 1 is registered with IP 100. So this is the one of the duty of IP 100. They keep on checking the connectivity of these instances. Okay, they keep on checking that IP1 is live, IP2 is live, they're still running. Maybe they might possibility the entire 1B data center goes down, or the hardware failure of EC2 instance, or maybe application has some kind of issues. Anything come up. So in that case, IP2 applications goes down. So now this is the duty of IP100 is keep on checking this application. Okay, this application uh, is properly healthy or not. And guys, this is concepts called health check. So they keep on checking the health of the application, and they keep on checking this application is still running, is still live. That's called keep alive. They keep on checking the still application is keep alive or not. And the good thing is, my parents say maybe there might possibility computer number two goes down. So they say now my applications is not alive, they are dead, uh, and maybe their health is not okay. So what we will do behind the scene, we disconnect this guy. Okay, disconnect this guy or de-register this guy. Okay, or there might be possibility that we can use one more term here, that applications 2 or IP2 goes down, hardware failure, or maybe data center goes down, or maybe possibility sometime we reboot the system, and rebooting the OS might take 5 minutes, 10 minutes, maybe depend upon application to application, right? So that point in time, guys, because system is rebooting, none of the client will connect. But I can't stop my client and let's say my system is rebooting and my system is in the maintenance state. Okay, so just wait. Okay, so technically for us, this computer is draining. Is draining. Okay, so maybe they're not fail, data center is not failed or goes down, or there's no physical disaster come up, but maybe possibility your instance is rebooting or shut down for some time, or put in the maintenance to maintain something. So they are draining over here. Okay, and if any kind of drain issue also come up, how to resolve it? Drain means they will also come in the future. It's not like they feel, but they are rebooting or they shut down for some time. Okay, so there's a lot of things we will discuss. I will like to talk about draining after some time. So to solve this, we use a concept called connection draining. What is that one we will discuss, guys? So don't focus right now on this concept. But technically, the good thing about the front end is front end is or reverse proxies or load balancer is okay. They keep on checking the health. Okay, or health is a one um, uh, who help us to solve the challenge that the way I started today. Okay, you know what I started? Okay, I don't want to lose my reputation in the company. If one of the instance goes down, okay, I don't want to tell to my customer that this is the application running and it is goes down to my customer. Okay, so this is not the great service you provide to the client. If your instance goes down, okay, it should be seamless. Your customers shouldn't see what exact happened behind the scene. Okay, your customer will still keep on seeing the application. For example, if I refresh here in Google, maybe the system through which I connected might goes down, or it has been put in multiple blocks. Facebook, Google, this company has hundreds of computer, either the corrupt, they goes down per day basis. But as a customer point of view, we never see this. Maybe this point out I refresh the system to which I connected last time might goes down, and Google has sent me to the different system, or because that system has a same exact copy of the website. So for the customer, for the customer, uh, for us it is pure seamless. Okay, but behind the scene they are using their load balancer, or using the reverse proxy, two component work together and giving this facility. But it's not a simple thing, guys. There's lots of things happening behind the scene. When I go for some more concept of databases or cache servers or session servers, right? So tons of things is there. Who maintain the session, who maintain the cache, who caches memory, or we'll discuss, guys, about memcached or redis. So in the top of this concept, guys, we keep on adding multiple things. We put backend databases, we put front-end databases, we put cache servers like Warnis, or tons of things is there, guys. So we will discover this. This I'm slowly building the complex infrastructure on the top of this example. Okay, so so technically, okay, whatever challenges you have, do you want to sorry, do you want to create a load balancer? Why? To handle huge traffic. If huge traffic come up, one single system won't able to handle. Because it is not the limitation of RAM and CPU or the network. Normally it's a limitation of your app server also, web server also, and maybe application also. So anybody who know about multi-processing or multi-threading, so every application come with a limited threads, and every thread normally have one session connected to that client, right? So by chance, who have are going through my Python classes in my IIC, so last week, guys, I was talking about multi-threading. So depend, guys, the guy who write the application, how much thread they have provided, so that means client can connect in one point in time. Okay, so lots of thing is there that will give you a limitation, that how much uh, uh, how many connections or how many connectivity my application will have. So if more traffic come up, more client come up, more requests, I can say, come up, load balancer gonna help us. Okay, and because there are a lot of computers run behind the scene, I don't want to give my client all the IPs, and it is not about hundreds of computers running behind the scene. So this is some concept come up maybe next week, where I talk about auto scaling. I will talk about auto scaling, and that point in time, guys, you will see this computer become very intelligent. Means as the load increase, this computer automatically start. Okay, and as the load decrease, the system automatically shut down. How it help us? It help us to solve the issue of costing, right, or money. Okay, because if my customer is not coming, so I keep on running my instance, because my instance is charging in the AWS per hourly basis. This is called auto scaling. So we'll discuss there how to implement this. Okay, but in those kind of scenario, you know what happen? What happen if this computer automatic launch? So that point in time, I don't know the IP address, so 131. Maybe IP might be 132, 133. Okay, so how my front end know what is the new IP? Maybe last time when this instant launch, IP was 131, then the shutdown, then the launch, the IP change. So they have to register, right? Okay, so So there's one more issue come up we will discuss in my auto scaling classes. This is called dynamic IPs. And guys, this is a very common challenge we have, because nowadays, okay, if you talk about some year back, these computer always has a fixed IP1, IP2, IP131. So telling to the front end reverse proxy, these are the fixed IP you have to use to do a reverse proxy. But now, today is a pure dynamic world. Every time IP change, either go to Kubernetes or Docker, something like this. So we need somebody who help me to auto discover what is a new IP. So we'll guys talk about this concept in very detail in my next classes. Okay. So so what I was explaining you here, if you need a load balancer, and because load balancer will have lots of IP, maybe static or dynamic, that is not important. So we need a reverse proxy. So we'll have only one single endpoint for the customer. Plus, I also want a somebody who keep on checking the health. Okay, because if system goes down, my bucket goes down, and my load balancers keep on sending, or I can say reverse proxies keep on sending the same to the computer, it goes down again for the customer. That computer never reply, and because they never reply, they will have a bad experience of not serving any services to the client. Okay, so these are the guys major things, but there might be some more, a lot more I can say benefit this program, or I can say front end provide to you. The front end. Okay. So guys, there is a lot of product available in the market who can give you a front end facility. That product you can install in one of the operating system. One of the very famous product in the market, through which you can set up the front end, maybe F5 big IP load balancer, or maybe HA proxy, if you guys know. Okay, or maybe Nginx also have this particular facility. Like this, like, there will be a lot of product available in the market, but we are not dealing in this training particular product like HA proxy or Nginx or XYZ. This training is about AWS. So the good thing is, good thing is in the AWS, if you want to set up this front end, right, then you have to manually launch one instance, maybe Linux instance, and on the top of Linux instance you have to install some software, and after install the software you configure it. uh, Plus it is not about only to configure, you have to manage also. What I'm talking about, my front end. So either you manage the entire reverse proxy or the load balancer. But guys, normally in the market we don't use much this term, reverse proxy. We always use a term called load balancer. But when I use the term load balancer, it always normally come with a reverse proxy. So you can think reverse proxy is one of the core concept provided by the load balancer products. Okay, so either guys you can configure your own personal load balancer to work as a front end, but for this you have to provide RAM, CPU. You to manage their downtime, because this is the OS, they will have their own personal RAM, CPU, and hardware and data center. So either you manage your own load balancer, right, or ask the AWS cloud, do you have any managed services? Managed services for the load balancer. And what managed service, guys, I already discussed to you in my last class. So managed services means AWS say, I will manage the entire load balancer setup for you. So I will launch the OS for you. I will install all the product for you, maybe HA proxy or whatever product I'm using, or maybe some kind of device I'm using. Okay, my team is gonna configure and manage for you, and you don't have to worry about the failure of this computer. Maybe the RAM or maybe their data center where I'm keeping this guy. Everything is taken care by my team. So I have my own managed services. Just you go and use it. Underlying architecture, underlying issues, you don't have to worry about. So if you ask Amazon, do you have any managed service for the load balancer? And guys, again, I'm repeating, when I say load balancer, I also mean to say they work as a reverse proxy. So for the AWS guys, they have a product called ELB, Elastic Load Balancer. So ELB is one of the product in the AWS. Okay, they will give you a facility of a load balancer, load balancer, and means they will also give a facility of reverse proxy. Plus all the facility by default load balancer reverse proxy come up with, right? I explain you like health check or giving one single endpoint, everything they provide us. So we don't have to worry about it. So if you search for in the service called ELB, okay, so you can see there's one service called or load balancer services provided by AWS, Elastic Load Balancer. Okay, so so maybe guys, a lot of guys might know how the reverse proxy work and how the load balancer work and what kind of normal challenges we would like to resolve. But I again explain to you as a summary or a quick summary, or maybe anybody who by chance doesn't know the concept, I explain you what kind of concept they solve. But today's main topic is about ELB, how to use the ELB. Okay, but one more time, guys, I would like to give you the way I set up this environment here. Okay, so it is always your design, it is your plan. You want to launch your back end server like IP1, okay, or maybe IP2 in the same subnet or in the same data center. It is same thing. Or you would like to launch your instance one in subnet 1 and one is subnet 2. So it is your choice. Okay, so it is your design plan. If you think this is very critical for the business, your data center miles goes down to launch your backend server in one and other data center, means in different zone. Okay, and guys, this architecture I will add some more point in this architecture of different zones. It will lead you a concept called cross zone. So cross zone is, guys, one of the great facility provided by AWS. What is the cross zone? We will discuss after some time, maybe today or tomorrow. Okay, but technically it look like that one of my server running in 1A, one of the my server running in 1B. So different cross zone we are running here. But my ELB or my front end server will work behind the scene for us, and for the client it is seamless. So what I mean by this, don't worry, very high level I already explained to you, but a little bit more about cross zone we will discuss. Okay, so let's implement this part, because for implementing the ELP, I believe you understood we need a VPC, we need subnets, and we need EC2 instances, and for the EC2 instance we need EMI. So everything we have, everything we know. Okay, already. So let's just start from here. So by chance, in my case, I'm in North Virginia. Okay, and if you go to service called EC2, okay, and guys, normally the load balancer we always normally use with sorry, with instances. So you will always see ELB, okay, as a sub-service of your EC2. So I am into the EC2 dashboard, and if you go down, so they have one service called a load balancer. So guys, can you hold for a second? So it is a one kind of sub-service over here. Okay, so I'll go for load balancer. But because before you use the load balancer, you should have your proper applications to be implemented. So what I mean by this, so what I'm doing here right now to start as a from step by step. So again, we have a VPC. Okay, so in my last class we created, even though if you haven't created, you already have one default VPC, and I'm going to I'm going to use one availability zone or subnet, let's say subnet 1A. Okay, and I'm going to launch one instance here, instance here in 1A. And what I'm going to do, I'm going to launch one more instance in 1A. We'll go for 1B after some time. So two instances I'm launching here. Okay, so now what you will see, because I launched two instances, so this will have IP1, this will have IP2. So customer need to know all the IP, and they will decide which IP they want to connect. but technically both the instance will have same exact application. Okay, so I don't want client will remember all the IPs and they will manually connect to each other. So I finally what I want, I want in this one A data center somewhere I will put my device or service called ELB that is managed by AWS, and this ELB has one IP address, let's say 100. Okay, so guys, according to my last diagram, it looked like we are configuring the ELB out of the VPC. It is not like this. VPC, sorry, out of the lab or subnet. It's not like this. I just explain you just for the sake of explanation here. But ELB instance, or I can say device, either put in 1A or either put in 1B. Some in some of the data center, obviously they have to put. Okay, so I'm putting everything, guys, inside 1A data center. Okay, and so finally, for the customer or client perspective, this they will only need to know only one endpoint called IP100, and I'll tell my customer that IP100 is your endpoint, but we have to tell my ELB that you are the front end, and finally, who will gonna use one of my client gonna use you. A client is on the internet. And guys, understand one thing, client is not always in the internet. There might be some cases come up, client would be in your own VPC also. Okay, what does those use cases we will discuss in upcoming classes. But I say because the client is on the internet, so we have to tell my ELB that you have to configure yourself as a public facing. Means you should have an internet connectivity, and because this ELB should have internet connectivity, so I have to put my ELB on a lab or on a subnet that's called public subnet. And what is public subnet? You guys know the subnet that has a internet gateway connectivity or subnet that their internal routers or other things will know the routing table of the internet gateway. So this concept I already explained. So technically we have to put the elastic load balancer in the public subnet. Okay, and after we put the elastic load balancer in the public subnet, we'll tell my elastic load balancer there might be hundreds of computer running running in this one A lab, but for you, you have to register IP1 and you have to register IP2 as your backend server. Okay, and by the way, guys, because they have to register two guys as a backend server. So first client request they send here, second client they send here. So it but always I have to configure both the guys or both the EC2 instance with the exact copy. And that is the reason, guys, it's always good practice to use a custom AMI. Okay, so and from this customer here I launch this guy, and from the customer here I launch this guy, so everybody has the exact copy of the EC2 instances. Okay, so let me start from here. So first step for my today's class is I have to use a custom AMI. So guys, if you remember my last class, okay, we have already built a custom AMI. So I don't have right now because my custom AMI I built on, I think, in the Mumbai data center, also in Mumbai region. So how to create a custom sorry AMI, you guys know. Okay, so this AMI I'm going to use today. uh, but there might be one challenge, guys, I might have I might have over here. The challenge is the challenge is this is the new account of AWS, and normally, guys, when you create a new account nowadays in the Mumbai, they give you some limits. Like in Mumbai, they won't allow you to launch more than one instance of EC2. Why? Because they give you one or two CPU maximum. So if you go to EC2 instances, if you go to limits and limit, and in the limit, if you go and check, I think in the last page, okay, in the last page, and if you see here in the last page of the limit, guys, normally for practice we use T2 macro instance. Okay, and if you use T2 macro instance for launching the AWS, so by default, guys, in the new account in the Mumbai region, especially guys, or maybe in the other region also, they give you only one CPU, one CPU, right? For the T type instrument, T2 micro. Okay. So if you see in your account, you will see only one CPU, and because of one CPU, you can, obviously with one CPU you can launch only one maximum instance. But in my account, I have a lot of CPUs here, so a lot of instances I can launch in the Mumbai region. And why I have a lot? Because when after I create the account, okay, I send a request to the AWS support team over here to increase the limit, and they increase. Okay, maybe first time they deny to increase, but they say after you use this account multiple times, then they see your history of usage, then they increase for you. So that's what they have increased for me. Okay, so I can very easily use Mumbai. That's the only thing. And this instance, so in the Mumbai I have this AMI. And if you remember in my last class when I create this AMI, so in this AMI, can you hold for a second? So in this AMI, guys, if you remember, I have I think if I remember, I have installed PHP. I put some web pages. I configure Apache server, make a service start permanent, something like this I've configured. So technically, if you use this AMI, one click and launch the instance, this HTTP instance will automatically configured as a as a Apache web server. Okay, that's what we are going to do. But guys, before I do this practical, I would like to tell you one more thing. Okay, when you launch the instance, even though let me show you also here, that makes more sense. So I'm going to launch an instance. Okay, and from my AMI, this one or whatever AMI you use. Okay, here I'm using T2 micro that has a one CPU. My account have 250 CPU, so a lot of instance I can launch. That's a good thing. Okay, so guys, when you launch the instance, okay, you guys know about subnet, but you have to also provide a public IP. Okay, and I told you guys public IP is not free. Somehow Amazon or any other company charge you. Even there's a free tier account maybe, but they will somehow charge you for the public IP. Okay, so understand one thing here in this example, because why you need public IP, why you would like to give IP1 or IP2 to the instance. Obviously without the IP nobody can connect. Okay, but guys, client is at the internet, and because client is at the internet means at the public side, so obviously client will have always have public IP. And I told you in my last class, public IP can only connect to public IP. Okay, so if client want to connect issue to instance, so issue instance also require public IP, second also require public IP, otherwise how client connect. But interesting thing is, guys, I already explained you, this ELP was also work like a reverse proxy. Okay, it means client request won't directly go to the AC instance. Okay, they doesn't go directly to the AC instance because this ELB service work as a reverse proxy, and reverse proxy is not a router. If this work as a router, then my request from the client directly go to issued instance. And I'm talking about router that don't have a netting setup. I'm talking about that kind of router. Okay, so technically, what ELB work? ELB will take the request one from the client. Okay, and they recreate the request as a new request and send it to their backend. And backend thing request come 500. Okay, so interesting thing, what can we achieve here in this setup? Okay, we can achieve by chance ELB issued instance both are running in one LAN, one subnet. And you guys know behind the scene they have a switch for the connectivity. Sorry, or because they have in the same lab or same subnet, and you guys know because they are on the same subnet, so they can have the IP from their network. Okay, and that IP can be a private IP, and guys till date we are keep on using the private IP only in the subnet. So what can we do? We can provide our EC2 instance a private IP, this EC2 instance a private IP, or my load balancer also have one private IP. Okay, and guys, by chance load balancer again have a two network card. One network card they connect to the private world, one network card they connect to public world, something like the router. So one of the network card of load balancer, let's say we give the IP called 3. So technically from the IP3, my load balancer can connect to IP1, connect to IP2, and that's what we want. That's what we want. So in this case, my EC2 instance are running with the main application. Okay, but none of the public guys will have a DAC connectivity. Okay, only the guy who wanna connect to this instance is IP3. In this case, is called load balancer. Okay, so there's no meaning. There's no meaning to provide a public IPs to this guy. It will save a public IP and save a cost also, and plus save a security also, because if you give anybody a public IP, so somehow they might get a DAC internet connectivity, and giving the DAC internet connectivity is again not the good thing. So a lot of things I think you can achieve. So finally, what I'm showing, telling here is, uh, uh, these instances will my main application, even though they are running in the public subnet, or because we are not giving the public IP. Okay, none of the client will able to connect from the public web directly, and we don't want to connect. They connect, even though I won't provide my IP address also. I will only provide one single IP. This IP 100 here. That's the public IP of my ELB. Okay, public, because I want to have only I want to give only one single endpoint. Again, this is the exact kind of setup almost every application use. Even though if you go to Google, if you go to Google, where it is. So this is also IP address or name, maybe same thing. Okay, and we only need so we only know one single IP or one single name of the Google. And you know what? You know what, guys? This is the IP and the the name of the Google load balancer. Okay, public facing IP address. So we actually connecting to the endpoint of the Google. Or behind the endpoint, they are running with thousands of computer, thousands of instances, and every instances, guys, they are running the same application. Okay, with the Google search engine application over here. Okay, and everybody has a private IP, because we don't require to give the public IP there. Why there's no use it, because none of the client will. For example, I am the client of the Google. I'm not connecting to their instance directly. So I'm connecting to this system. This is the load balancer IP of the Google. They take my request, hold my request from my behalf, send to the internal one of the private IP as a load balancers also, because other client will send to other load other system to balance the load. They get the output from that guy and they will send it back to me. Okay, so almost every application in the world will always has a public facing load balancer that also work as a obviously reverse proxy. Okay, so in this example, guys, we don't have to give a private IP. And one more interesting thing, by chance by chance about a security group, because this concept we already discussed in detail. Okay, so finally, guys, this instance till date, guys, you know what we are doing here. When you launch the instance, we launch the instance. We always give instance that anybody in the world wanted to come on this application, for example, application running in HTTP or port number 80, allow it. So we are allowing everybody in the world in the firewall. But now none of the guy on will come to instance directly. The only guy that come to issue instance is my ELB. So to my security group, or maybe to my NACL, not the NACL, actually NACL go work outside the network. To my security group, we have to tell only one thing, that if any request come from IP3, that is my ELB or load balancer, to this instance issue to allow this guy. Okay, apart from nobody will come, right, directly. Okay, so it's, guys, the one of the great security measure is, or security feature is, least privileges. If you go to any of the technology, if you want to implement the security, this is the principle we always follow. Right? This is a core principle and the most important feature, most important principle of the security. Give the least privileges. Only allow that part that is required. Otherwise, deny everything. Okay, this is the best, one of the best principle, important feature principle for the security. Okay, so my technically my EC2 instance is only finally connected by ELB that is running IP3. So why we have to allow all? Only allow IP3 of my ELB load balancer and deny all, for this guy, and otherwise deny everything. Okay. And why we require IP public IP? Don't give public IP because client never not going to connect directly to this guy. Okay. So guys, it's a good good. If you want to practice ELB, you can actually launch and practice. It's very simple to use, but by chance we know security group, we know subnet, VPC, public IP, and all the concept. So I'm trying to implement all the concept in this diagram or in this practical. Okay, so let's do guys step by step here. So what I'm doing here, first of all, in the Mumbai data center, I don't need this. It's running. Okay, so in the Mumbai data center, I am going to launch two instances. Okay, so launch instance. Okay, I'm launching for my AMI. I believe it is tested already. Okay, but guys, let me test this in AMI one more time because I want to show you one more thing here. Okay, so I'm just launching this instance and normally the way we always launch, because I want with the public IPs here. I'm using public IP because I want to show you something. Okay, very small thing, but it is important to know. So this is the web one maybe, and by time I'm allowing all the guys for HTTP because this computer is running with HTTP protocol for anywhere in the world. Okay, and launch and use some key. Okay, I want to show you something, then we'll go out for this practice. Okay, and understand one more thing, guys. It is always a good practice also in the terms of security. Okay, like if you remember till date, whenever we launch any EC2 instance, we always provide a SSH key. Okay, why? Because SS key is like a password. So from our laptop, maybe till date, guys, we are using putty. So from our laptop, right, we can do a remote login. Okay, via SSH, and while remote login, we provide a username and we provide a password. And guys, by chance password here is my private key. Okay, so why we are doing SSH? Right, till date, if you think we have to do SSH or remote login to this instance, okay, for only for one reason. Sorry, there's only one reason, and the reason is to configure this guy. There is no other reason. I don't to run the read command, mkdir command, yum command. The only reason is to do a remote logging to this instance is why SSH is to configure this guy. Okay, so I can say SSH is a protocol. Okay, and it's for management, to management of ROS. But now today, today, I am going to launch the issued instance for my own custom AMI. And AMI, guys, we already configured. We don't need to configure anything here. Okay, or because you always already configured. So why we have to provide SS key here? Because we don't have to log in. Okay, don't have to log in, and because you don't have to log in, why we have to provide a password or the key? Again, guys, the list privileges say, right? If you give up, if you enable the password of using some key, even the key is very powerful thing, nobody else can break. But by chance somebody stolen your key, so they will have access to your instance. For us, it is okay, but thing is, a corporate perspective, this instance might have very critical financial information, right? I don't want to leak any in any of the form. Okay, so you think you don't have to log in, you don't do some change here in the instance. So it's good for the security. Don't enable the key. Okay, means don't provide any key. It's like a lockdown. Means lock it down. Lock down the things. Okay, so nobody can able, even though you won't able to go inside it because there is no key associated to this instance. But by chance in this instance, your web application, right? So only way to connect this guy to access the website, and whatever guy you provide in the website or web pages, only that part can be accessed by you or by other guys in the world. Okay, But in this instance, I given my my key, me, just for a small reason, because it's been long. I haven't used this AMI. If some part is missing, the thing application I wanted, I can go and log into this instance and see and to configure this guy. But by the guys, in this instance, I have given a public IP, and according to my knowledge, in this IP, I've configured some PHP website. So if I go to this IP, public IP, and I think I might have configured the page called index.php. Yeah, so thing is working great. Okay, thing is working great. So you know what I did. So very important point here to be noticed. Okay, so this is the one of the computer running. Okay, at this IP. Okay, and as a human being perspective, what I did to check this computer or this IP is properly working or not. I manually type this URL, or I can say I type this endpoint manually in my browser. And what I did, I did one testing and testing for connectivity. And when I see this output, when I see this output, okay, this output say that whatever you guys want to connect to the application, okay, it is connected. You know, one more interesting thing here, very small but important interesting thing. If you see the output, this output has a lot of meaning. It means your instance running, your PHP code running, your web server running, website is not down, your hardware is properly working, your entire data set, everything is working. Also, entire data center is working. Okay, so getting this output, output means means every component whatever we require to running our application is working. Okay, so we test this. And guys, by chance anybody who know anything about uh, this URL, this URL guys, you know, work with the protocol called HTTP. And whenever we get the proper output from the HTTP, it's called success output. So whenever guys see any success output, behind this in they send a code that's called success code number 200. Yeah, obviously if you write some other pages that is not available, you get a error code number 404. So enter guys, you will get the error code number 404. Okay, the success code. So why I'm discussing this point here, because very important, because right now we are testing this application, but I am going to put my this application right as a back end application, and my front end would be my EL. So how EL will check the health of this guy? So ELBs keep on testing this guy. Okay, for this we have to tell my ELB, okay, in my website we have one of this page. Because normally guys, in the website you might have hundreds of pages. Okay, so one of the page URL we have to provide to my ELB. And I'll tell my ELB do one thing. Okay, I'm giving the page name called index.php. I am also giving the IP address of this guy. I mean, you know, the entire URL or the endpoint. Just keep on going there. Keep on accessing this page. If you get the output, technically the output is, when you get the output, you don't have to worry about this output. Maybe output might have some data images. So for you, it is not important. For you, the important is success code 200. So if you get the success code 200, it means your backend server is still up. Health is fine. So if health is fine, okay, so whenever any client from outside world come to you, do a reverse proxy, send the request to guy, get the output and reply to this guy. But maybe because this is a computer, it might fail in the future, might fail in the future. So because you keep on checking the health, so I'll give you some kind of timer here. You can think something like this. Okay, so so just keep on checking for example, like for example, every minute, every second, or every 10 second. Okay, or after 10 seconds you'll see again you connect to same URL, but you're not getting any reply, or not getting 200 response code, I can say, or success code, I can say. So think there's some challenge in the system. Maybe data center goes down, hardware failure, system rebooting. So don't wait, hold the client for more time. Do load balancing concept and send a request to the other backend server. get the output from there and get reply to client. So for the client, everything's seamless. For the client, we don't have to wait. They don't have to wait for us, and and you keep on serving the client. So point is, guys, here how elastic load balancer or any load balancer come to know the backend side is down or not. So they keep on checking the health. And how to check the health? For this, we have to provide one of the page name, okay, through which they keep on checking. Okay, so that's the one thing. So that is one of the reason, guys. Sometime in our websites, we always create some kind of testing page, for example, test.txt with some small content. Okay, and this page we create for the ELB for testing, or maybe we can give some of my home page URL or some other small page URL, whatever I want to give here. Okay, so guys, while configuring ELB, you'll see this kind of page come up, or this kind of configuration screen come up, where you tell ELB that you are going to configure some backend backend engine, or sorry, backend server. Okay, um, tell me how we are going to check the health of this, guys. So you have to provide this information. You need to use this page or URL to check this. Okay, so that is the only reason, guys, why I wanted to launch this. Right, so technically my AMI is great, there is no challenge. It is pre-config Apache with some PHP code. My PHP code is printing the output of ifconfig command of that OS. Okay, and what are the printing here? They are printing the ifconfig command, means the IP of the instance. And if you guys compare, this IP is exactly the same of this IP, private IP. Okay, so everything is good. So I don't need this instance. So let me terminate and start from the scratch. So let's start, guys, from the scratch for configuring the entire setup. Okay, so this kind of setup we are going to configure now, guys, because we know lots of concepts here. Okay, configuring the ELB won't be a big deal for us. Okay, so let me start from here. So first of all, I'm going to launch two instances. Okay, so I guess just go to launch instance. I'm using my own AMI. Okay, or if you don't have the AMI, you can manually launch two or configure for you. That be your choice. And again, I'm using T2 macro. It's not important here. I'm launching two instances here. Or auto scaling group will see. And not actually, I'm not launching two. Let's launch two. Okay, and I'm putting into VPC we have created, or let's go for default, because maybe some of the guys might don't have the VPC. And I'm putting into in one single data center called 1A. So it is something exactly same setup I'm doing here. Okay, and because we don't require any public IP, so we're disabling public IP, save our money, plus security also they improving for us. Okay, so this part, guys, we have done. So next, storage again is not important at all. Tag, I'm just giving a name called web for load balancer, right? OS. So just tag name I'm giving. As this tag name maybe not so much beneficial for you right now, right? But if you anybody know a automation tool like Terraform, like Ansible, okay, this tag is very much critical, right? So I'm not discussing over here, but it's very much critical. Anybody who watch by chance with my Ansible training, or maybe in the future, my if you're part of my Terraform training, uh, without this tag, it would be very impossible to do some kind of great automation. Okay, but right now it is not so much important. mm, any value you can give. Okay, security group. I already explained to you the power of the security group, but I don't want to make this right now this topic a little bit complex. Security group, just for a while I'm allowing all traffic. Obviously it's not at all good for security, but we'll change, guys, this security group. Okay, so that's one. And finally review and launch. And I told you guys, because this is a pre-created AMI and good for security, we don't want to log in to this OS, so I don't want to attach any private key. So this is the maybe the first time we are doing this thing, proceed without the private key, right? Without a private key. It means nobody gonna can log in, even though they will get your private key, but private key is not attached. So how gonna they use it? It is like them. I have locked down uh, my instance here. Okay, so it's good for security. So two launch instance launched for us. Okay, a launch for us. But if you guys notice here, let me search for web. Sorry. If you notice here, both the instance won't have a public IP. Or with a public IP, okay, nobody can able to connect. Because right now I'm in the public world, but this instance running in Mumbai in the private world, in the private lab, and they don't have a private IP. Okay, so nobody can connect. Okay, and for this we have to use ELB. So by chance, if you see here, this guy don't have a public IP, and you guys know with the private IP you can't connect from outside world. So that's okay. That's what our plan is. Okay, that's what our plan is. Now, according to my current setup, okay, according to my current setup, we have one instance running here and one instance running here. Let me take the guy, or let me give the IP here. So this instance has a IP 145. So one of the IP of my backend server is 145. Okay, and other one has a backend IP called 52, and both the IP is private. And if any of your public internet client want to connect, they can't connect. Only way right now here, okay, that will give all the facility is to put ELB. But in the ELB, we have to provide some public IP so they can come over here. So to make the ELP a public facility. So now, guys, next plan is to configure the ELB. Okay, and guys, I will highly recommend all of you, because you guys know how to configure everything from the CLI. Okay, initially, guys, I talk a lot about CLI and I give you the pros. So what a practical I'm doing today, I highly recommend it. If you can do the same practical after, first do with this kind of graphical way, make yourself comfortable. Okay, then do the same practical with the AWS CLI. Okay, and give you a lot of knowledge. And by chance, anybody who by chance know Ansible also, just try with the Ansible. Okay, so a lot of extra benefit, you guys, you will gain from these practicals. Okay, so yeah, so let's go to guys load balancer. So in this page you will see the load balancer here. Okay, so before guys go and create a load balancer, it's so simple to create a load balancer. I just want to tell you one small thing that will discuss in very detail, most probably tomorrow. Okay, so in the AWS, guys, nowadays they provided uh, three different kind of elastic load balancer. Okay, one is called or typical, when they start the ELB services, they come up with this load balancer called classic load balancer. One is application, very interesting, you will definitely enjoy this application load balancer. And one is very powerful in the terms of performance, is called network load balancer. Okay, so this two topic I will take tomorrow. Okay, today I'm going to configure classic load balancer. I can say also the older one, or the old generation. You can also use the word. This is called, these two are new generation. Okay, or I can say traditional uh, load balancer of the AWS. But my main point here is not about new and old. First, I want to make you comfortable with the concepts, and I think this is the right point to way to start to give you the concepts. After become comfortable, then tomorrow if I talk about ALB or NLB, it won't take much time. Okay, but it doesn't mean we always use ELB and NLB. Mostly, and most time we also use CLB also, classic load balancer. So when I explain you all the three, you will see when to use what. Okay, so today I'm going to for classic load balancer. So if you click on create load balancer, You will see three load balancer here: ALB, and LB, and CLB. Classic, previous one, old generation. So I would like to discuss about classic load balancer today. Okay, Creed. Here they're asking you, can you tell me a load balancer name? You can give any. For example, I'm giving Linux World ELB. Simple name, right? Or hyphen CLB, classic load balancer. Just a name. Okay. And I told you guys, whenever you want to create um, a load balancer, you have to put in your VPC, okay, and maybe in your subnet. But here they're asking you only which you want to create a load balancer in which VPC you want to connect. So two VPC I have, but I'm using my default VPC. Why? Because the instances that I launch in my subnet and the subnet I was using for my default VPC. So technically, I'm putting into my VPC, but Amazon guys behind the scene will launch this load balancer in your respective subnet. Why? I will show you in a minute. Okay, I will show you in a minute. So I'm going to uh, create put my load balancer in my own office, means my VPC. Okay. Now one more terminology, guys, I would like to give you here. But one more small thing. There's one option called create internal load balancer. Very interesting use cases we have for this, but I don't want to tick here. It means by default they will create a public load balancer or public facing. Means they will have a public IP. Anybody can connect from outside world. Okay, so by default they will create a public load balancer for you. But there's a great use cases, guys, we will discuss in the terms of management and the security where we need internal load balancers. Okay, but one more terminology I would like to give you here is okay, whenever, guys, anybody want to connect from one computer to other computer. Okay, let's say this is the computer IP1, IP2. So I think we already discussed somewhere, but from IP1, if you want to send to kind to IP2, IP is not only enough. Okay, maybe in this computer, maybe multiple applications running, multiple services running. So you tell IP1 that go to IP2, and there's one service running, a service name called application 2. You have to connect to this service. Okay, so that IP1 will send the request to IP2 and tell the IP2 that which service they would like to connect. Okay, so for this, guys, in the networking world, for every sub application we give some unique number, and by chance those numbers called port number. So technically, if IP1 want to connect to any application, they have to tell two things: the IP address and the port number. Without any of the information, it is impossible that any client can connect to other applications. Even if you go to Google, okay, you also tell this. So I would like to connect to this IP, or you don't type, or you type, you always give a port number 80 or maybe 443, depend which kind of protocol they're using. Okay, so port number, guys, if you always give, or if you don't give, you have some client application they put by themselves as a standard port. Okay, so I'm discussing this point here because because your client is there on the internet, and for the client perspective, right, elastic load balancer is the real main website. So they come on the IP address of the ELB, but without knowing the port number of ELB, how they connect. So even though there's no application running, but we'll tell my ELB, let's do one thing. Can you launch one port number for us? Okay, so you can start any port number. Let's say I will start a port number called 8080. You can give any port number. Okay, so we'll tell this IP address and this port number of client and say, if you want to connect to my website, come on this IP and this port number. But when this request come to this IP and port number, you'll be say, I know I'm no website. I will take the request and send it to this IP. But again, in this case, ELB is the client for this web server. A web server say somebody from here coming to me. So if ELB coming to web server, so again ELB should know the IP address and the port number. And by chance, guys, normally when you configure web server, they are run on the port number 80. So my AMI web server is by default working on the port number 80. Okay, so technically here there's two port. One port that we give to the client, that's the ELB port, and other port we will give to ELB, that is my backend server port number. Okay, so by chance this port number is also known as, so any client come to your server, or for example IP1 go to IP2, so IP1 have to tell to IP2 that I would like to connect to this port number, or IP2 will say, hey, this, for example, this port number is 80. So IP2 say, my 80 port is in the listening mode. They're listening to your request. Just come to me, tell me the number, I will help you to connect. Okay. So they are known as a listener. So technically, what I'm talking about ELB, while configuring ELB, you tell what is the port number or what is my listener port number. So any other term you can use here. Okay, that's what they're talking about here. Okay, so if you see here, they're talking about, can you tell me the load balancer listener? You can give any number here. Okay, it's up to you. Let me give 80 according to my diagram. So this is my load balancer port number or the listener. Okay, or I can say this is a public facing port number because we have public IP of the ELP. Okay, and here you tell the instance port number. So here, guys, you can't give anything. Okay, you should know in IP145 what kind of service you have configured, and in this that service which port they are running on. By default in Apache website, what we are running here, they work on port number 80. But if you change it, so you have to change in the setup also. Okay, but in my case, I haven't changed my by default port of the Apache web server, or whatever I'm using, I'm using the same number here. Otherwise, they won't have a connectivity. Okay, so this is one kind of setup we have to do. But guys, if you know anything about web server, a web server by default, for example, IP1 is a client and IP2 is a web server. So IP1 connect to IP2, by default they use a protocol HTTP, but there is other protocol also, HTTPS for encryption. So these guys also support this HTTPS, TCP, SSL, other also. So we'll have some small discussion on this in this CSA training about HTTPS and security. But right now I'm not discussing here, but we will definitely discuss about other protocol also. But in my case, my web server is purely work on HTTP, but we can convert in HTTPS also. What I mean by this, we will discuss in the future discussion. Okay. Now we go to next page. Here they're talking about a security group. Okay, and you know what is security group? Technically, technically they're talking about, okay, your ELB, guys, even though it's not set by the AWS, but technically behind the scene ELB is also one kind of instance. You can think one kind of OS. Okay. Okay, and because they are the OS, so obviously they also require some kind of security group. Security group. Okay, so here they're talking about in the ELP what kind of security group you want to add. And obviously anybody from outside world can connect to my ELB on this port. But obviously they come via ST port. ST port. Why HTTP? Because finally they will have a website access. So my client will come to my ELB via this protocol on this IP on this port number. And so guys, we have to create a security group for my ELB. Okay, guys, it is not for backend server. It is only for elastic load balancer. Okay, so I'm going to create a new security group. And let me give the name. Let's say this is um, web elastic load balancer, CLB load balancer security group one. I'm just giving some name that allow port number 8080. Okay, and here I'm saying I'm allowing HTTP traffic on a port number. Guys, understand one thing. By default, this rule name is pre-given by AWS. If you use pre-given name, they won't allow you to change the port number. So in my case, guys, we are using S3. We want S3P protocol to allow, but my port number is customized port number. It's not 80 80 80. So for this, what you have to do, you have to go for a rule called uh, custom TCP rule. So anybody who know about networking, uh, HTTP work on a concept called TCP. So we allow TCP, and my port number is 8080. Okay, and I would like to allow anywhere in the world. So that this security group we have configured for the internet client, so that they can come to my ELB. My security group, my firewall won't stop them. So that's what guys I config. Or to make it simple, just for practice, just you guys go and allow everything. That your choice. But because we know security groups, so I'm just again revising those concepts to you for you. Now go for next part. There some kind of warning come up. Um, uh, you allow traffic for all the directions or internet. That's okay, right? So we just go for next, guys. Now this page is the health check. And what health check I explained to you. So I'm telling to my elastic load balancer that we are going to add some backend server to you. How you check the health? So for this, just go to this backend server to via HTTP protocol, because they are the actual web server. So go via HTTP protocol. And guys, this concept is called ping also. So just keep on pinging to the HTTP protocol. Ping means here check the connectivity. Okay, and we have to go to the port number 80. Port number 80. Okay, but in this instance, how you check? Okay, how you check? For checking, we have to access some page. So here I have created one page for you, or we already have some home page for you. Just keep on getting, or just keep on grabbing this page. If you get this page and there's no error come up behind the scene, obviously 200 messages come to you. Status code, it means there's no challenge in the connectivity. My instance is up. Okay, so that's what we have to do. So for in my case, guys, I don't have this page. I show you already. My actual page or actual path is slash.index.html. Why I'm using slash here? Because finally, if you go to that direction, that example here, okay, my ELB will know my IP address. Only thing to the ELB to tell about this path, where your page located. Slash, if you say slash index.html, or maybe your page may be located in some other folder. Where is you located? You have to provide it to your ELB for health check. Okay, this one. If you don't do so, if you don't give the health check information, okay, your instance will fail hand check, and they will removed from the load balancer. Okay, so it's very critical. If you give the wrong information over here, he'll be for example, if I give a wrong page here, for example, this may be index 1234 php. If this page is not available in the EC2 instance, my ELB won't able to get it. And they think, even though my instance is running good, or maybe my applications in Portamati HTTP protocols are running good, but according to ELB, they were not able to access this page or this path. So they think there is some kind of challenge in the connectivity. They are not live, they are dead. So they will remove from the load balancer. Okay, and this system will won't work as a backend server. So they won't send the traffic to that guy. Okay, so this information is very simple, but it's very critical. Okay, so that's what we have done. So what is this detailed response timeout unhealthy threshold? It is again related to how frequently they keep on trying. So we will discuss guys about this number. Don't worry, even though they they have given this information, the time to check when response comes for health check. Okay, or how frequently they keep on checking. Okay, help. I explain you amount time between the health check. Okay, so the first check 5 second, again this come 5 second, then 5 second, then 5 second. They keep on checking. so so if you think they keep on checking health, the timer you can set. Okay, so you can say ELB just go every 5 second, every 10 second. Okay, so the interval that is allowed is 5 to 300 seconds. So if you give 2 seconds, it won't allow you. Okay, so the available health check timer here is called actually interval. Allowed interval is between 5 to 300 seconds. Okay, so you can give 5 seconds also or 300 also. It's all depend upon requirement. Okay, if you give lesser time, it means your ELBs keep on coming to your website every 5 seconds. So somehow they will impact the performance. Okay, but we think your backend application is not so much critical. If the down for 1 or 2 or 3 minutes, okay, it will be okay for you for final client to wait. Just increase the time for 200 second or 300 second. 300 second means around 5 minutes. So if your instance goes down, my ALB never come to know till 5 minutes they are down, and the client, because they keep on sending, so client won't get the final response, but ELB never come to know they're down for 5 minutes. After 5 minutes, they make it dead. Okay, something like this. So guys, don't worry. We'll talk a little bit more about unhealthy this threshold, but in the help you can see very clearly what they're talking about. I will discuss. Don't worry. Okay. Now this is screen where we are going to add our our uh, computers or backend systems. Okay, so now by chance we are running with two backend servers, and you might also see some kind of terminology here: cross zone and drainage. Very high level, I have given the name, but I will explain you not today. Tomorrow, I will explain you about this concept. Okay, um, guys, if you can give me, guys, please 2 minutes. I just want to. I just come back. Just give me 2 minutes. Then I'll show you how to add, and then I'll show you final demo. Okay, just give me 2 minutes, please. Okay, so finally, they show you all the instances running in all the zone over here. So by chance, I have two instances running. Both are in 1A because we have launched these two instances in the same zone. But if you have multiple zone instance also, they will show you here. Okay, so technically right now what you have to do, you have to register your backend server. What I mean by this, you guys know. Okay, behind the scene, okay, you are running with the two instances here, EC2 1 and 2, and you're telling to the ELB service that there's two backend server IP1 and IP2 are running in 1A. Please go and connect or register or work as a take these guys as a backend server. Okay, backend server. But you know what I'm doing here? I'm not taking this guy as a backend server just for a while. Okay, so my so finally, sorry, finally what you will have, you have one device and service running ELB. That's all. Okay, and there will be no actual back end servers you have. Okay, that's what it means. When you create this ELB, obviously they will give public IP. And if I provide this public IP to my final customer, and they can reshare, they can connect. But when they send the request to this ELB will try to send to one of the backend server. But because they don't have any backend server or they are not the real website, okay, so how they behave and what they will reply to the client, that's what I want to show you right now. Okay, so I don't want to connect any of the backend server to my ELB. So I'm not selecting any of the screen here to add the issued instances. Okay, so click next. Just give some name, just some tag name. Might not be useful right now. So my ELB tag, something like this. It's not at all important right now. Okay, then sorry, review, and this is the complete review. If you think you want to change something, change it. We don't want to change anything here. Just create. So finally, guys, they are configuring the load balancer for you. There is some issue in the timeout. I think I updated some timeout. Is I think the interval was 30. There's a dependency actually in between 1 to 2. I will explain you what is that dependencies. Okay, so finally you can see your classic load balancer has been created. Very beautiful. It might take some time. Okay, so you can see here, if it takes some minute for instance to become active in the load balancer, means they're taking that telling to you elastic these backend server okay, will register to the instance is called, they become active. It takes some time. Okay, but in our case, because I haven't connected any of my backend issued instances, so there is no meaning of this line. So I think there is no meaning of any active or registering the backend server. But at least my ELB load balancer is up. Okay, so let me close. And if you see here, if you see here, my elastic load balancer is up. Okay, and if you notice one small thing here, okay, in this elastic load balancer I haven't add any I haven't add um any instances. Okay, that is a reason, very reason. If you see in the description down, status 0 by 0 instance in the service means in in this um, uh, load balancer you don't have any any instances running. Either you check from here or there's option called instances. You can check also from here. So there is no install register to this load balancer. Nothing is here. Okay, this is one thing. Second thing, if you very interesting, if you notice here, notice here, this elastic load balancer, if you see as a availability zone name, okay, they are working in the all the three availability zone. Okay, what is the meaning of this all three running? Okay, we I can properly explain it tomorrow when I add go for cross zone. Okay, but technically they're talking about if you are instance in 1A 1B 1C in Mumbai, they're only talking about the Mumbai because I'm in the Mumbai. Okay, so I will give a connectivity. You don't have to worry about the connectivity. So if you have any disaster recovery plan, so you can launch one guy in 1A, one in 1B. I will help to connect both the guys that I'll show you tomorrow. Okay, so there's a reason, guys, if you see in the instances. Okay, because by chance I don't have any instances here, but they also show you because you are in Mumbai and you launch the load balancer in Mumbai. And guys, by the way, load balancer is a per regional service or regional services. So you create a load balancer in Mumbai, you can not see in North Virginia. You can access. Why? Because this load balancer will have a public IP. You can access anywhere, but you won't see in the other region dashboard. But if you see in the Mumbai in 1A, I don't have any instance connected. There's no instance connected. Okay, there's one small thing. Second thing, I told you guys, when you create a load balancer, they will give public IP. Okay, so if you see here in the description, here they give you a public IP. And by the way, guys, uh, they doesn't give the IP. Instead of IP, they give the name. And normally in the load balancer, name has a great use case, right? So when I go from a DNS topic, it's called Route 53. I will explain you why name is very much beneficial apart from the IP. One of the reason you guys know, when you connect a Google, we don't type the Google IP. We always give the name. One of the reason is remembering the name is simple, but that's not the important reason, right? There's some technical reason behind it. Okay, but technically they give this name. This name you can think it is like a public IP, like www.google.com. Okay, and if you see here, the scheme is internet facing because my this load balancer by default is internet facing. Is not a private load balancer. Okay, but if a yeah, obviously it is a classic load balancer application and network load balancer we'll see tomorrow. So if you connect to this load balancer, okay, kindly load balancer. Okay, so technically you can think right now I'm the client and I'm connecting the public IP, public name of the load balancer, or it is also known as DNS name of the load balancer, public DNS name. Okay, so what we'll see here, guys, if you see here, they keep on waiting. And guys, whenever you see this message, keep on waiting. Mostly the answer is a firewall. Firewall doesn't allow you. Okay, but guys, in my case, I already enabled firewall. But the challenge is again they're showing this screen because we know our load balancer working on port number 8080. When you send the request, by default, this request go to port number 80. Okay, so because this is the endpoint of my load balancer, and we enable the port number 8080, plus we enable the firewall on port number 8080. So you have to give the port number of your load balancer. Now there's some different messages come up. Okay, different messages come up. There's no waiting. It means technically we have properly connected to this load balancer on port number 8080, and there's no firewall challenge because we already allowed the firewall to this guy, even though um, somewhere in the security group, you see security group. If you click here, you can see we already allow port number 8080 in the security group. So we see here, so 8080 we are allowed for everywhere in the world. But again, you get the error. And if you see here, is not currently unable to handle. Okay, so technically, this load balancer is saying you're coming to me asking to give my application, but I don't have any application. Anybody who wanted to come to me, I always send to my backend server, but because I don't have any backend server to handle your request, so I am giving some kind of error like this. Okay, so I just want to tell you, load balancer don't have any application. That's the only point. Or load balancer purely rely on the backend server. So now, guys, let's go and connect the backend server. Okay, and how to connect backend server? It's pretty simple. So this is my load balancer running. Okay, and I'll go to instances. And if you see here, I don't have any instances here. So I just click on the edit instance button, edit instance button. And just for a small demo, I am going to connect one of my backend server running in 1A, only one. Okay, this means I'm registering only one instance as a backend. Okay, now if you see, is out of service, but if you refresh, is out of service. If you refresh, is out of service. And till date, guys, it out of service. If again refresh, nothing will happen. Is again unable to handle. Okay, but if I again refresh, it's in service. Why this issue come up? But technically, my load balance service say I have one backend server with this name in 1A, and now they are active. Active means in service. They are in service. Like even the keep running, they're in service. So it means anybody connect to me, I will send a request to backend, and whatever backend will reply to me, I send to you. So let me show you where this key. So now guys, this time, if you refresh, you can see this output. It's a great, interesting output, guys. Why interesting? If you see in the top, your URL doesn't change. Your still client is still connected to the load balancer. This is the still the IP of the load balancer. It is still the port number of the load balancer. But we get the reply from a backend. How I know? Because we know our backend server is configured with this content. Even though backend server runs some PHP code. In the PHP code, I run ifconfig command, and this is the one of the IP. We have written this IP somewhere. Okay, so this is the one of the reply come from this IP because this system we have connected. Okay, so this system send the request to ALB. ALB is the one who sent the request from their own, right, to the system. But if you again refresh, again there's no reply change. A reply is coming same IP. Right now ELB doesn't work as a load balancer. Why? Because we have only single instance. So how they balance the load? So for the load balancer, at least we require two systems, right? Then only they will balance the load. Okay, so now what I'm doing here, okay, so I'm going to add one more instance. Okay, and as soon as I add one more instance, okay, now again one more come up. If I keep on refresh, you will see in some second they will status will be in service. It means that system will register to the load balancer. Now is in service. Okay, and if you notice, guys, last time this system take around maybe 10 seconds to come in service, and this time I think it might take 4 or 5 seconds to come in service. Why this time difference we have? But technically they are in service. Technically, both the system connected as a backend. That's a good thing. So according to my load balancer, now they have two systems running as a backend, and both the system you can see here, system one, this one, they have the IDs, and both the system is running in 1A. Yes, they are connected. They are healthy. In service means they are active. Okay, and because there are two systems connected, now if you go and again connect to load balancer from the client side, right, in this example, if you see here, right now, if you try to recall my entire class today, okay, we might have two or maybe hundreds of computer, but you don't have to give all the 100 IP to the client. You have to give only this IP and this fix and this port number fix for the client. So for me as a client, as an internet client, this is my endpoint. You can think this is like a google.com. But when you connect to the google.com, this load balancer or this load balancer here is called ELB. They will connect to hundreds of thousands of computer as a load balancer. Okay, and how I can check? But by chance I connect two system, and by chance for testing I use a instance that will give me IP address of that system. So what you will see when I connect to this guy, last time you see the IP was 145, and as a client if I again connect, you can see IP change. It means they have connected to IP 52. Okay, and as a client if I again refresh, again this to connect to same. again 145. They normally they have some caches information in the browser, so they won't show in one go. But if you keep on refreshing, you see IP change 145. Now I connect to this one 145. So it's a great practical. So finally load balancing happening. Okay, and because we have two backend server, two backend server, so so both is working very fine for us. Okay, but in this both the case, as a client perspective, guys, I am a client, internet client. I never know the IP. By the time I'm printing the IP just for testing, but actually I never know the IP. For example, Google is connected to one of the backend server, which server they connected, which IP and private IP they connected, where they're running, which data center they're running. We don't require to know. It's completely designed and architecture by their architectures, right? Architect guys. um, um, our duty is, as a client, we have to just know one IP and one port number. That's all. Okay. But everything is, oh, maybe maybe one of the computer goes down of Google. We don't have to worry about. They will keep on connecting to the other system. Same thing here. Okay. Same thing here. If you are, if you shut down one of the computer, or remove one of the computer from the load balancer, for example. Okay. So let me remove, let's say the first one from the load balancer. Now we have one computer, and now if I if I again connect, okay, now if you see here, they are balancing the load one minute. Why they are doing so? Because because they have a time out, but after some time you'll see I still connecting 52. And guys, the best way to test the application in the browser, normally they have a caches information. Browser sometimes won't give a exact answer what we want. So I suggest guys, now they still connected to 52. Okay, only they connect to one guy, and they are connecting to this guy. And if you see the IP of the system is, you will see is 52. This instance, and the IP of this instance is 52. But I highly suggest guys to checking this kind of setup. Don't use browser. Browser has copy some caches information. So copy this URL, open your command line, or use a curl command. Okay, the curl is a client side, browser in the CLI browser, I can say. So you can see same output come out, same output come out. So they only connect IP52 because we have only one backend server. Okay, but if you want to add more, again connect, same thing you can do. Just go to instance, added instance, again add more. Maybe have your more traffic out of service here. If you guys see again, they connect to 52 only. Okay, 52 only, 52 only, 52 only. Why? Because this instance is out of service. And why they out of service? Now they are in service. Now they start doing load balancing for us. So first time they connect to 52, second time they connect to 145. Again 45. And they might connect for some time for some instance due to some kind of uh, performance reasons, cache performance reason. But after some, because technically I am the client, I always want to connect to one. I will guys talk about this concept maybe tomorrow. This called affinity rules. But you can see, I connect for 145, then I connect to 52. Load balancing happening very properly to us. And why this status takes some time is because of the health checks, these numbers. I'll talk about this healthy threshold. These are the one why we take, it'll be take some second to make it active. Okay, there's some reason. This is purely based on these timers or this intervals. Okay, so this is a one thing. So I think guys, you got the higher picture about how to configure ALB and some of the concepts. Okay, but there's lots of things we can discuss about this one, about listeners. There's a lot of things we have when I go for a network load balancer or application load balancer. Okay, and plus stickiness and all the things we will discuss, guys. Corrosion, all the things. Okay. So I think till here we'll just conclude the today's class. Okay, today's class. But this topic is very important, guys. Even though if you go to Kubernetes, okay, Kubernetes also have a managed load balancer, and if you use launch a Kubernetes on the top of cloud, like AWS, they use the same load balancer. Okay, so technically we don't use a load balancer directly. On the top of this, we use other services like Kubernetes. That is highly recommended, even though we are launching one batch on 5th January. You guys might know, okay, about the CKA or CKD. So through this service, actually, we launched the application. Right now, I'm launching the application on the top of EC2 just for testing, but technically, we don't do in this way. We actually launched the application on the Kubernetes, and Kubernetes is one who use this load balancer behind the scenes. So a lot of layers actually we use, and this is something known as hybrid cloud setup. So that's what we do. So in my Kubernetes classes, we will discuss those part in very detail. Okay, but but this setup, other use require, otherwise thing won't work for us. Okay, so I do this practical. I explain lots of things from very zero. Okay, after you become comfortable, just try to do the same setup with the CLI command. Okay, this one thing, and that's all, guys. So anybody who are from the earth, right, we will see you guys after at 9:15 in the YouTube channel, and we are discussing Python there, right? So again, very important topic we are going to discuss today. Okay, so any questions, guys, still here? So any questions, any point you have? Anything about DNS, guys, don't worry. In my upcoming classes, uh, we have a class on DNS. Uh, so in Route 53, AWS will discuss. Man is 8088 is just a port number you can give anything, right? It's not so much critical. It's just a number to connect. Yes, Rahul, load balancer by default use around robbing mechanism strategy, but there is other also. We can configure other strategy also, but normally they use round robin. Upon this is a great question you asked. I don't know which context you asked me about the front end. Oh, sorry. Yeah, I thought you asked me front end cache actually. So it's a great concept of cache memory management. Different products we have, but your question is different. What if the front end get crash? So again, this again one great question you have. So guys, what Pawan is asking, if your elastic load balancer fail, what happened? So again, the entire system goes down. And so that is the thing, guys. We normally create multiple load balancers, and this load balancer, guys, will again load balanced by one more service called DNS. So there's the guys one more role of DNS come in play. Okay, so that is one of the reason why they give the DNS name instead of the IP address over here. So I will, like, guys, explain you this concept in my DNS classes, but we can create one more DNS, so one more load balancer on the top of other load balancers. So one of the load balancer go fail, so it will fail over to the other load balancer, right? So what I mean by this, in my DNS class, I will explain you. Like an as such, ELB doesn't support cache. It's not the duty of ELB. For this, we have to add extra caching server like a Redis or memcached, something like this. No, Nikhil, HA proxy will also have a keep alive checking. Okay, so you don't have to manually check the alive status in the HA proxy also. They will do for you automatically, but you can change the timer. That's a different point, but they will check for you. How to integrate machine learning AWS? Pankaj, some of the class of machine learning with AWS I will do in my Earth classes if you are the part of Earth. But yeah, obviously in CSA we won't do because for machine learning we have a different advanced program in AWS purely on machine learning. So uh, any prerequisite for Kubernetes classes? As such, Karthik, no, there's no prerequisite. Only basic knowledge of Docker and container we require, And for this, we are sharing to all the registered student my Docker class in YouTube. That much knowledge is enough. So one or two class of initial of Docker is much more than enough as a prerequisite. Otherwise, Kubernetes I will going to start from very basics. So does load balancer also have a limit? Yes, definitely. Every device has a limit. There's a document from the AWS. If you want to search it, otherwise I will give you the link where they give you some report of per connections limit in one point in time, and how we improve and other things also. Sometimes we have to go for network load balancer also to improve the latency. But there's a lot dynamically they will increase for you. Okay, so there is in the give the name called ELB, called elastic. So as the more requests come up, elastically internally they increase for you, but they have the huge limit. Before lockdown, Ludo had 8 server. Now it is 200. We actually didn't understand what happened. Okay, great, Subhasis. Whenever you see anything, if suddenly applications become grow, they become um, uh, they become scalable. I will explain those things more in detail when I go for auto scaling. Everything behind the load balancer are going to help us. Nishant, I haven't talked about cross zone or drainage. Maybe tomorrow I will explain. Okay, so I just wanted to give you a term, a very high level, but tomorrow I will explain. Please take class on Azure also. Yes, Akash, we are planning for Azure classes also. Can we use backend server by different? Yes, Pranav, you can, and this will be one of my practical tomorrow. Yes, Prithviva, you can also configure a physical router as a load balancer if they have a support. Some of the router in the market come up, they have a support for a load balancer. Not all the router has. Okay, so you check your configuration or feature of your physical router. No, Kalpit, Google was not down because of attack on ELB. There might be other reasons, all right? Uh, or Google is not using ELB service from AWS, but Google had their own load balancers. Okay, but logic wise, they're using same. So that's all, guys, for today, and see you guys tomorrow. And we will keep on continuing with this topic, and lots of interesting concepts we are going to discuss tomorrow. Okay, that's all, guys. See you. Bye. Take care.